Everybody, Miss Berry here again. Another example of how to graph a quadratic function that is being shown in intercept form here. We already did one example. We'll do another one right here where we're just worried about the straight algebra. A couple of different things we're looking for here. Of course, we need 5 points, and when in doubt, we can always go ahead and just pick random x values. But in order to have the most accurate looking graph, we'd like to go through a certain process. We want to make sure the very first thing we do, especially when we have it in intercept form, is look for those x-intercepts. So I'm going to come over here to the function. The things inside the parentheses here, x minus 1, x plus 3, those things right there will help me get to an x-intercept. Again, I'm looking for the scenarios where we would have zeros inside of those parentheses. So we set those parentheses separately equal to 0. Here I have x minus 1 is equal to 0. Hopefully we understand that x value of 1, if we put it in there for that parentheses, it would make that parentheses 0. So somewhere on this graph we will have an x-intercept of 1, 0. Then I go ahead over to this parenthesis right here. I got x plus 3, trying to figure out what would make that parentheses 0. Subtract 3 from both sides and I get x is equal to negative 3. So here in this problem, for this function, my 2 x-intercepts, or at least I have 2 x-intercepts and 2 of them. One of them is 1, 0, the other one is negative 3, 0. So I'll go ahead and plot those points on my graph right there. Next thing up, once I have those intercepts, what I'd like to do here is try to figure out my vertex as the third point of the potential 5 points that I'm looking for in this problem. Do recall that there is a mathematical way and then a picture way to do this. Maybe you're able to look at these dots right here and figure out what x value would be in between those. Maybe you need to go ahead and use a formula. So just for math purposes here, let me go ahead and try to figure out where the x value that would be in between those. I take my 2 values in there, and I'm trying to figure out the axis of symmetry. And in order to do that, I'm going to take them and add them together. So I have 1 plus a negative 3. And I'm going to divide that by 2. So the midpoint between 1 and negative 3. 1 plus negative 3 is negative 2. And if I divide that by 2, that would be at the location negative 1. So the axis of symmetry here for me is going to be at the location x is equal to negative 1. Do remember that that is a vertical line that goes the whole way up the graph, and it's imaginary, so it doesn't really count as part of the graph, but it certainly helps us when it comes to finding the vertex and eventually using it as a mirror. The axis of symmetry here is x is equal to negative 1. In order to get the vertex, I need to find a y value for that location. X is equal to negative 1. I'll take the negative 1 and I'll plug it in to the original function. So we have here y is equal to 4, and I'll plug in my x value, negative 1 for x. Everywhere I see an x, I'll plug in negative 1. Do the math work here. I have 4 out on the outside. Negative 1 minus 1 is negative 2. Negative 1 plus 3 is positive 2. Again, no shame in using a calculator here. 4 times negative 2 is negative 8. Negative 8 times 2 would be negative 16. So I did that right there in order to find out where the vertex would be. And the vertex for us in this function would be at the point negative 1, comma, negative 16. Unfortunately, here for this picture, when I try to graph this thing, I might run off the chart. We'll see how I do, and maybe I'll try to estimate down here. This, will happen. 2, 4, 6, 8, 10, 12. So I'm going to be guessing 4 more spots here. 2, 4, and we'll go somewhere like right there. Not necessarily the best situation in the world for us in this problem, that's alright. But I do want to make sure that I'm aware that since my A value here is 4, and that's a positive number, that indeed, you might have already picked this out from the other points on the graph, that this point right here is our vertex, and it is going to be a minimum for this situation. So again, our A value is positive. Our graph is going to be going upwards. That means that this is the lowest point, and that would be our minimum. One final thing I want to do here, hopefully this works out. If not, again, we can always just pick points to plug in. But I have 3 points already, the two x-intercepts. I have our vertex here, -1, -16. I'm going to try to figure out if we could get a y-intercept. So two x-intercepts in this problem. I'm going to go ahead and figure out if I can get a y-intercept. So in order to do that, what I need to do is understand that a y-intercept would have an x value of 0. So when we have a y-intercept, our x value is always 0. I'll take the original function and I'll plug 0 in wherever I see the letter x. And I'll have 4 times 0 minus 1 is -1. 0 plus 3 is 3. Multiply it out. 4 times -1 is -4. -4 times 3 is -12. So another one here where we're awfully low for our point that is at the y-intercept 0, -12. 0 from the original x, -12 from the calculation. So let me go ahead and grab that. I believe I'm right there. That's 4 points. Let me try to get one more. And the way that I would like to do this, if we have a y-intercept, is to use the mirror and put it on the other side. Just for argument's sake, I'm going to go ahead and I'm going to draw a table of values here. I have x and y values. My vertex, we know, is in the middle at the point -1, -16. I had a point at -3, 0. I had a point at 1, 0. I had a point at 0, -12. So again, if we understand the concept of the mirror here, we know that 2 spots away from -1 is -3. If that y value is 0, 2 spots from -1 is +1 on the other direction, on the other side of the mirror, and that y value was the same exact thing. So without too much thinking, or at least not too many calculations, we should be able to figure out another y value that has -12. What would the x value be? -1 to 0 here is 1 spot away. 1 spot away in the other direction would be -2. So maybe you're able just to look at the graph and kind of understand that there's the mirror right there. So here is a point on the right side. A point on the left side would be the same exact situation right there. And I'm going to try my very best to connect the dots here. Again, it's supposed to be looking like a letter U. Obviously this is pretty tight and we're off the chart. So I'll try my best. Obviously a little bit of grace involved in a picture this tilted. We come back up and there we have it right there. So I have my parabola. Granted, it's a little bit off of our chart, and that's all right. I have 5 different points that I have gotten. Started off with 2 x-intercepts, got myself an axis symmetry in order to help me out get a vertex. Got a y-intercept and was able to mirror the y-intercept to get our 5th point in this problem.